Welcome to Crypto 4.0 Artificial Intelligence channel. Today, I will present the Artificial Intelligence Supervised Machine Learning classification applied for crypto classification. Before starting the presentation, I just would like to go through this glossary. That's artificial intelligence or application of computer based on mathematical methods and algorithms to deal with data and provide information such as alerts, classification, prediction. Machine learning is a method based on mathematical statistical methodology that is used to provide cluster classification prediction that will be applied for crypto. And then we have the different classification of machine learning. We have unsupervised machine learning that aims to cluster, group different, in our case, cryptos in different groups based on their features. We have supervised machine learning that is based on previous data that we can do classification prediction. The difference between supervised machine learning and unsupervised machine learning is that unsupervised machine learning do not use previous data, past data to predict future data. They just use the data and starting to clustering this data as it's presented. So it can be done continuously. So we have, as I mentioned, supervised machine learning classification. That's the main objective is to label some, in our case, cryptos in some categories. In our case, will be huge market cap, medium market cap, small market cap. That's a label that we give for different cryptos based on their market, the level of the market cap. And then of course we can also have machine learning regression as I presented before. So the previous video I made some of the presentation, the content and the general overview about the supervised machine learning regression theory and with an example, and then I started to, there's other videos that make the case explanation how you proceed step by step to predict a crypto price that you choose. I used two examples. The first one was Bitcoin, the second one was XRP. And then in the future I will make more prediction for other coins as a classification. This video will clarify classification. So just remember that we have different machine learning methods. What we are working now is machine learning. So we have different methods applied for data, depends of the objects. As long as our objective, initial objective here is to make the prediction, classification, clustering, we are focused on machine learning. So again, just remember the concept that when we have machine learning for classification prediction, we have a data set. So we collect, in our case, 200 the 200 coins data that are the rank of from the first Bitcoin to the 200 coin in the rank concerning market cap. And then based on this data set that we use in our example, we split this data in training data and test data. So training data will get 70% or 80%, and test data will get will be split. We will have 20% of total is a 200 data. So, and then of course we need to choose a model similar to the regression model. There will be different methods here for classification, and then we will get the method that have the highest accuracy. So in case of regression, we use mean square rooted error as the main parameter to decide which model we will choose for our prediction. Here, because it's a classification, we have other parameters to check and to choose the one that is more accurate for classification. And this accuracy I will explain later on how this is calculated, but in the end we also have a parameter to choose which model fits better in our data. And then of course I will do verification based on what's the values, I can make verification checking training and test data. As I mentioned before, this is very important to see if your model is overfitting. If you have 100% accuracy on your training data, the model is overfitted. So that means when you come with new data, probably your classification will not be good, cannot be good. So you need to be careful with overfitting, as I mentioned before, and also you need to be careful with bias and variation. So, and then of course, in the end, when I use new data, I will check the accuracy and validate this model. And then of course, that's the idea, the main idea behind the machine learning classification methods or regression. The machine learning in general is that as long as I have constant input of data, the algorithm of machine learning, these models will be classifying or make a regression automatically. In our case here, classification. So the whole idea is classification is that I have a data set here. I have x-axis and y-axis. So this can, let's say, can represent variables. So here we do not have more, let's say, the concept of independent variable. Independent variable that we use in prediction. Independent variable is the one that we want to predict. Dependent variable is the one that we use and take influence on independent variable. And here we only use dependent variable. There are features of our object of study, in our case crypto. For example, you can use market cap and volume of transactions, or market cap as or ranking in this list of cryptos from the first to the last one. And then of course, based on it, I can create 3 categories. And then the idea of classification is, as long as I use the current data and label this data, here is ABC, in our case will be high market cap, medium market cap, and low market cap. So whenever a new data comes, depends on this data location. For example, if the data is here, the models will trend to classify as a A. If the model is here, the model will trend to classify that as purple, C, and so. And if it's around here, the new data depends on, of course, the X and Y value. For example, market cap and the ranking, for example, 2 variables that I can use to classify the cryptos. So I will have classification B that can be medium, large, and cap. So these are the general concept. There are different methods to do that. We'll look on it soon. So before that, I just would like to understand the concept of confusion matrix. And here, the confusion matrix is basically this matrix here, that you can see different class. So this was about risk classification, critical, indifferent, and moderate. Then the matrix shows how much percent of this data are properly classified. So whatever the data come in the diagonal here means that the predicted numbers of data that was predicted as a label C was real, classified as C. So here we have Fort data that was predicted as C, and this Fort was classified as C. So we have here, 100% similar to indifference, here similar to this moderate. And that is this concept that we have in concerning true positives, false positive, true negative, and false negative. True positive is the number of predict positive variables that is positive based on real classification. False positive is the number of predict positive variables that is negative on real classification. So in our case, if I have one here, one value here, for example, that means that this value is predicted indifferent, but in reality is critical. So that is false positive. And positive and negative when I have 2 variables. And I can say that in my case here, critical positive and the others are negative. So I choose one as positive, the others as negative. So in this case, we apply for 2. So if I had a simple matrix like this matrix is 2 for 2, so I have these 2 categories. So this is positive, this is negative. But I can use these 3 also categories and also define these 2 as negative. So, and then we have 2 negatives, so the others that's not positive. In our case, for example, if I get these 2 here that are not positive, the positive I classify as C, so the other categories are are negative, and then the same concept. True negatives, I have these are considered negatives. Then let's say these I have true negatives 60 because they were the 6 that I had, that was E was predicted as E, and this third that I have class label as M was predicted as M. So and that is false negative is some of them are false predict. For example, if I have the 1 point here, so they were predicted M, but reality is E, so it's false, what we call here false negative. But in the end, this is a very good graphical demonstration. Whenever I have all data here in this diagonal, means that all the accuracy is 100%, that all data were predicted. When I have data here outside of this diagonal, main diagonal in this matrix, means that false classification. That's commonly used in that's normal in when we have data and classification. And then that comes the concept of accuracy. So the accuracy is the calculation that we add true positive plus true negative, and we divide it for the all possibilities: true positive plus true negative plus false positive plus negative. And in our case, as we have 100% true positive and 100% of the total of results, we achieve 100% of accuracy. We have also other index, recall, precision. That's in the end the most important one that we use is accuracy. Okay, another concept that we see in the when we apply a machine learning classification is this concept of ROC, receiver operation characteristics, and then they use true positive and false positive heights. So they calculate these heights, and the idea, they also use true positive and true negatives. And the idea is to create this graph here. So this graph shows when it's 100% in here in this side, when achieve the error is 100% achieved, it means that the model classify far more true positives rather than false positives. And then they just shows as much as one, better is the classification. In the end, that's what this graph shows. But I think that in the end, the reference that we need to use is the confusion matrix. Is very simple. You look on diagonal, you see how much data was real classified, what is outside this main diagonal are wrong classified, and then I look on the accuracy. And that's what we're going to do in our example in the end when you compare different models. So now let's take a look on different supervised machine learning classification methods. As I explained before, similar to the, let's say, regression, machine learning, supervised machine learning regression. In supervised machine learning classification, we also have different methods here. We see that, for example, in some cases, tree classification and support vector machine and neural network was also applied for regression. Then we can also, we have the similar model, it's the same concept but with some differences to classify, to label data. We also have this here in the, let's say, classifications. So the first method that we use is the nearest neighbor, and the as known as KNN method. The KNN aims to classify new data that consider the set of data already classified by the previous data set, and then they use to calculate this data based on the distance. So what does it mean? Remember our picture that we saw at the beginning. So as I mentioned, if new data come here in this region, this nearest neighbor will look on the points that are closer to them. So they will look on this point, the distance between this point to this point, the distance between this point to the purple one, for example, the distance between this point to this orange one. And then the ones that shows that have the lower distance, so the closest one is closest for a point that is blue, they will be classified in blue. If the point now is in the purple region here, and then they will look on the closest point to them, and then of course he's in this region. The closest point is this one, and then they can also compare with this blue one. He's closest to the purple point rather than to this blue point. So this point will be classified as purple. So that's the main principle of KNN methods. So based on distance, so they can use different methods, the Euclidean distance and others. We not go deeper on that, but just the idea about the concept of KNN method. We have also decision method we saw decision method can apply it for regression, and we can also apply it for classification. So the idea is that the model will label the difference. They have different labels. Here the labels are green, yellow, and we have here blue. And depends on the value of the variables. So here we can see, for example, if x2, so we have x1 here and x2 here. If x2 is the question here is how this tree is built. So if x2 is higher than a, so yes or no, so we consider no. So is lower than a. So that's x2. So lower than a, they are in this region here, this value below, lower than a, let's say this point. They can still be classified as blue and yellow. And then I come to this gate here, and they will ask, okay, now I look on x1. If x1 is lower than c, I have x2 here. If x1 is lower than c, for example, I have this x2 and x1 lower than c. Okay, the point is close to it will be classified in this region blue. If it's higher than C, so of course they will be yellow. So this is basically the tree model and how the decision tree classifying data based on the values of their variable. If higher or greater, depends on the region, they will classify and label the data. So we have ensemble methods, and the concept of ensemble methods is basically they will use the principle of majority voting. That means they will combine different individual trees results to make the final decision. So basically, we have some example of ensemble methods: boosting. We have also bagging, and the difference between boost and bagging, that's the boosting, they split their data sets in different samples. Bagging use the first sample and use this first sample to generate the second sample, so on. But that's not important. It's just a detail. The main idea behind the ensemble method, that's they have a database. They split this database in small samples, and each sample will have a tree, and then this tree will have a decision. In the end, the final decision will be based on voting. The majority of the values of classification will be the results of the ensemble method. So if we have 4 trees here, if for 3 of these trees in the end votes have as a result, for example, that's crypto is measured, is a huge margin cap, and the other one is low market cap. So in the end, the majority of these 4 is large margin cap. So the crypto will be classified as a large margin cap. So that's how it works, the ensemble methods. So another method that's we are also already checked for prediction is the naive method. So again, naive method is objective is to define the probability that a given points will be labeled to a class based on condition probability. So just remember, we have this concept of condition probability. So here in the end, the probability of B, what's the probability to have a B, since we have A is based on A, since we have B, for B multiply for probability of B divided for probability of A. And then the main point here, naive method. Why is naive? The name of naive comes from that's actually when we do this prediction of this conditional probability, we do not consider dependence between variables. So that simplify the method, the calculation, as presented here. And then we want to maximize this function in the end to calculate the probability. And then we do not use, we can have different variables to predict one label. And that is the main concept. So if we can see here one example to make clear, we have here different parameters. We have education level, experience, maintenance, reports, and certification. Then we want to classify if this, let's say, if this, if a number of candidates that we listed here are expert or not. So that will depends on the level of education or the level of experience that's defined here, the level of maintenance reports, and the level of certification they have. So we can have experts and no experts based on this combination of these values. And then of course how the naive methods do this calculation. They start to calculate the probability to be an expert and be educated and be an expert, and be experienced and be an expert, and so on. And then they calculate this probability by using the total values in here. For example, the probability of the C+1 probability to be an expert, they just calculate how much professional here we have and how much experts we have. So we have for let's say for 20 here, if 10 of them are experts, so we have 50%. So this probably will be 50%. It's similar that we have for the others. So how many for these 20 are educated and experts? So educated, we need to consider higher than 2. So we check here education higher than 2, how many we have, and then we calculate and so forth. And then the model will calculate the probability that's they are labeled as an expert and no expert. So whenever we come new data, in this example, new candidates, they will have these features, and that's will be labeled. We have different scores here, and then in the end they will be labeled expert and expert. So linear discriminant analysis, another method for classification. Basically, linear discriminant analysis aims to define the classification based on a variable class that's from different categories. And the main objective here is that this model, they define a straight line that can be a plane also, and then they project these points in these lines here, and they see and they try to maximize the distance between the mean and the mean of these points and also the discrepancy between these points. They make an index, and we check if the new data is in one region or another region. Depends on the region that the data belongs. They will be classified as let's say as one label or another. In our example, green or yellow. Another method that we have is a support vector machine. As we had in the regression, support vector machine can also be applied for classification. It is quite similar to the concept of a linear discriminant analysis. However, rather than maximize the distance between mean values of each class points, the supervised machine maximizes the distance of the closest point of each class by considering the margin. So as we discussed before, we have the tube that is a characteristic of support vector machine. And then we check the points that's exclusive of each margin. So whenever a new point coming, let's say here, this point will be measured, the distance from this point to this margin to this margin. Meaning, if it's close to this margin, they will be classified as yellow. If it's yet now here above, if it's closer to this margin higher than the other margin, they will be classified as green. So this is general concept that support vector machine uses. We also have another model that's logistic regression. Logistic regression, the name is regression, but actually it's used for classification, and that's very simple concept. You have a sigmoid functions that will produce values. Depends on the values that you have. You will look on here, project in the sigmoid functions, this logistic function. You see here in the axis we have the probability. So we have one class here blue, another class here as red. So if the sigmoid functions for the logistic regression value is 1, and we project here this one in the logistic line, we'll see that the probability to be blue is very high, is close to 100%, and then the data will be classified as blue. By the other hand, if the value of the sigmoid functions come to -1 here, then they will be projected in the let's say here in this logistic line, and then the probability of will be very low, so they will not be classified as yellow, and of course they will be classified as red. So that's the general concept. Here we have an example of sigmoid function. So we will have here a linear function here. Then by applying the values of linear regression, we get these values here of sigmoid function, and then we project in the logistic line here. Then we get the probability. Depends upon the probability, you have one label classified as 1 or blue or red in this example. And of course we have a neural network that can be used for classification and can also be used as was used for regression. In the same example, we have variables values here, x1 and x2. We have waves, and then we'll have some linear equation, and in the end we'll have a value of the functions here of the fx function. This fx function actually this will be used in the sigmoid function. And the sigmoid functions, this is one example, can be other function as well, but just to simplify here, I just consider that we have a classifier in this neural network. We have a classifier function as sigmoid, and then this value will be again projected to the logistic line, and then we have the probability to have one class or the other. So, and that was done in this point here. We have classifications, so to the one side, to the other, and in the end. So that's why a neural network is applied. So now let's try to apply the supervised machine learning classification concept for classifying and label the different cryptos in large cap, medium cap, and small cap. So large cap is something, small cap is something zero between 2 billion, medium cap between 2 billion and 10 billion, and large cap above 10 billion. So this is the first label that we're going to do. We need to go again in the CoinMarketCap or other website. I collect the data from CoinMarketCap, so just copy and paste all this data, and then of course this is raw data. I need to prepare the data as I wish. So what I'm using from this information here, I do not use all information, so I use the ranking, the name, the market cap, the price, and the value. Then I need to add this classification here. LC means large cap, MC means medium cap, market capitalization, and S means small cap, small market capitalization. So I need to prepare that, and then of course what I'm going to do, I will input this file to our MATLAB software. Then based on this data, I will select two of these variables that in my case will be the market cap and rank. Then I will run all the models of all classification models, and you can see that the models here for when we apply supervised machine learning classification, they will produce accuracy, and the ones that have high accuracy is the best model to apply. So on the right side here I can see the confusion matrix, and as I explained before, you can see that here in the main diagonal of this confusion matrix, we have all right classification. I have only one misclassification here, only one medium cap was classified as small cap. So there is only one mistake, 200 data. That's why it's 99.3%. When I compare the sample model with other models, for example, supervised machine learning, that I get 77.9%, and others here, for example, neural networks, the same. I can see that the ones that produce a higher accuracy is a sample. That's why I will choose this model. And similar to the previous model, now when I have a training model, I use a training model for a new data set. So, and then that's what I've done here. I use this function. This is the function that I have from previous model, and then I use new data sets. So you can see here, this is a new file name, and then the model automatically produce the classification, and I will get this classification. I will include in here. So this, and then we can compare the real classification and what's the model predict. Then we can see that it's a perfect classification. There is only one missed value here below. That was again one of the coins that should be classified as medium market cap, and it was classified as small market cap. And that's of course I can since I have a training model and the accuracy is very high, I keep going to classifying these coins as long as past the time. And then in the coming future of December next year, I keep looking and classifying this data. So the main point here is to observe how these small cap and middle cap coins going up to the rank, and that means these small caps and middle caps are the gains, the highest gain that I can have. So we're talking about, when we're talking about large caps, it's between 2 to 10x gains, 10 times what I invest. When I talk about market cap, is around 10 times to 50 times, and then of course 20, 30 times, 10 times, between 10 and 30 times, some cases 50 times what I related to what I invest. And then small coins, when they upgrade to this medium cap or even large cap, that is something around 50x to 100x related to what I invest. And then that's why it's very interesting to apply this classification and check the movement of these coins from classification and regarding also their rank. So another important to realize here that there is a relation between my prediction price. I can use also prediction to predict market cap, and then whenever a coin have a new market cap and price, of course they will have a higher classification when there's a market cap and price goes up. And I can use the prediction, so mean I can predict a future market cap and price, and based on that I can also check what will be the classification of this coin in the future, and based on it I can take my decision about what is the best investment. So this was the video that explained how we apply supervised machine learning classification for crypto coins, classification, labeling, prediction in market cap levels. If to upload the MATLAB software, you need to go to this website. If you want, I will explain, I will demonstrate later on in the channel some examples performed in R and even in Python. But as I mentioned before, the advantage to use MATLAB is because by using MATLAB you don't need to know about how you need to code, and you don't need to understand the specific mathematics. You just need to follow up step by step. And that will be about our next video. In our next video we will present this case step by step, how you collect the data, how you prepare the data, how you input the data in the MATLAB, how you prepare the classification machine learning methods, and then how you select that based on accuracy, higher accuracy, compare different models, and then how you, once you have your training data, how you can classify new data set. That will be the next video, and you see that step by step. So thanks for your attention for attend this video class. So I see you in the next video.